And we are live. All right. Hello, everyone, and welcome to the Robot Party for this month of February. In the future, we're going to try to have them once every 2 weeks, so twice a month. But if you're new to the Robot Party, so what the Robot Party is it's a hangout for robot builders, and so anyone can join in if they're a robot builder and talk about their robot, and then also get feedback about their robot, like if they did something that they need. Please mute your mic. Please mute your mic. You are getting muted. Sorry, dude. Sorry, Chris. Alright, who's not muted? Okay. Anyway. So you can show your robot on the Robot Party, get feedback on it, and even get help from other robot builders. And there are also people who are robot enthusiasts who watch the Robot Party, and from there they get to learn about different robots that people are making, since there are always lots of robots in the world that can be made. Okay, so last time we had the Robot Party back in January, we had lots of fabulous robots, and we're obviously looking forward to the robots again this time. And if you want to interact and ask questions, there's two ways of doing it. There is first the questions and answers app on the Google Plus Hangouts. So you can reach that on the Google Plus Hangout page, and then there's a button to ask questions, and we'll be able to see it live. And you can also use #RobotParty on Twitter, and that way you'll be able to do this from whatever device you're on. And after the Robot Party, you can join the community on Google Plus, the Robot Party Rockstars, for the after party for a few weeks. A continuous after party, yeah. Okay, and we'll have more info about the dance-a-thon coming up soon. But first we'll dive into the robots that are here. So let's see. First up, let's go to Andrew. He's been working on an interesting robot, apparently. Oh, and also, sorry, one more thing, one more housekeeping thing. Anyone in the Hangout can ask questions, so feel free to just ask the questions whenever, because that's why it's a Hangout. Okay. Andrew, tell us about what you've built or what you're building, and who is it for, and everything.
Yeah, so I've been keeping this project under wraps for a while. It's a robot I built for Popular Science. It's going to be in their print edition, which I'm pretty excited about.
Their what edition?
In their print edition, in their Popular Science magazine. So I'm really, really psyched about that.
Yeah.
It is a robotic hand that uses pneumatics or compressed air, and it's based on some work that was published by Harvard. Harvard published a really cool soft robotics kit, and they show you how to make a number of different actuators, and also what they call a fluidic control board, which is just a bunch of electrically controlled valves and some control stuff. So the thing I didn't quite like about their toolkit was a lot of the techniques were maybe a little outside of my comfort zone, and maybe a lot of hobby robot people's comfort zone. You had to make custom molds or use special materials or techniques, and so I kind of adopted one of their actuator types and used just some simple rib tubing from from a pump, and it's got balloons inside. Here, hang on. Let me show you guys a close-up here.
Yes, close-up.
So what you're looking at inside, the gray stuff inside is a balloon, like an animal balloon, but it's a sort of an extra thick one. And then this is just tubing from an air pump. And the sides, I drilled little holes, stress release holes, and cut slits along the top. So when you blow up the balloon, the end is taped up and some hot glue in there. And the balloon expands, and the only place it can go is to let the finger bend. And I just used an old toy for the hand and kind of put it all together. And it took a little experimenting with the materials, but I got it working pretty good, finally.
So by working pretty good, what do you mean? Like, what can the robot hand hold?
Well, I'll show you. I can demonstrate it. But
yeah,
let me show you.
Let's see it in action.
Yeah. All right. Here. Hang on a second. I'm gonna turn it on. All right. It's also a little loud, and it makes some quite funky noises. So.
Okay.
All right. So here we go. I'm just gonna try and show you the first finger here. And then you can kind of move each finger individually. And then I also programmed in some set behaviors. So that was sort of manual control of each finger, but you can just kind of program the whole hand. I have another mode here where there it's kind of pointing. Here, it's supposed to be kind of come this way. That's supposed to be tapping fingers. Here's the fist. Here, I'll show you. Hold something. Hang on. Let's see. Where am I going? Okay. So if I just kind of put a screwdriver in here, it's not really a great gripper. It was more to teach myself some concepts of soft robotics and pneumatics. But now that I've kind of touched it, I'm going to play with it some more, different techniques and such. Let's see. That's a hand signal some of you may recognize.
Yeah, it's the broken robot hand symbol.
Anyway, that's the idea.
So how long have you played around with this? Just like toggling the switches?
I actually, the majority of the time was just finding a good way to make the fingers. I've got an entire box of broken fingers that different fingers that didn't work out so well, and sometimes the fingers do break, and when they blow, it's kind of amusing because sometimes it'll break out the tip of the finger or through one of the slots, and the balloon will just keep blowing up. So it'll be sitting there, and a huge balloon starts coming out of its finger. It's kind of silly looking, but that doesn't happen nearly as much anymore. I had a lot more failures early on.
So this is essentially sort of going to be like a gateway into the soft robotics toolkit.
Yeah, absolutely. So
I think we lost your video.
Oh, hang on. There we go. Sorry, I'm not sure what happened.
Me neither. Okay. So where do you think people will go, say they make your robot after seeing it in the magazine? Then where would they go after that? Would they jump right into using the toolkit to make their own soft robots, or would they have to learn how to create the molds first?
I think that there is a lot of opportunity to try different techniques now that, once people see what's possible, new ideas, I think, come up, people will be creative. Like I'd be kind of creative to come up with this, and I probably worked. It might have been easier for me to learn mold making than it was for me to do this.
Yeah.
But now that I've done it, first of all, I had to make an investment in making this board, which I'll show you real quick. The board has a Arduino Mega compatible board here, and then a sensor board on top that just makes it easier to plug things in. I've got 12 and 24 volt power. I can switch up to eight high power switches there, MOSFET switches, and then that can drive. This is a manifold with 8 pneumatic switches that can turn on and off for the to push the air. So now that I've got this board built, I could do anything up to 8 different pneumatic controlled elements. I would try to make different different types of actuators from the toolkit that still use pneumatics but are a totally different type. They had kinds that can contract or expand.
Michael is showing a little tiny image of Baymax.
Yeah. Yeah, absolutely. So yeah, maybe Baymax is next. But I think I just wanted to demonstrate what was possible, one thing that was possible, and I think people will come up with really cool ideas.
Yeah, neat. Another thing, where was the air compressor in that? I'm not sure if we saw it.
No, we didn't. Now, I have a giant, I just happen to have already a giant air compressor, not giant, but decent sized.
Oh my gosh, roller coaster.
Yeah,
oh, wow.
Yeah, so I've got a decent sized for scale. But you don't need one that big. It only takes about 20 psi to run. So you could use a much smaller air compressor, and in fact, the design that Harvard publishes uses a different technique that basically has a pump and a regulator type setup, I think. So you could use that. It just happened to be I already had a regulator on this, and it was easier for me to do it this way.
Wow. Well, very cool robot. I'm sure lots of people will be interested in getting started in soft robotics this way.
Yeah, I hope so. It's one of those things that you see a lot of you see a lot of news items in robotics on different cool soft robots that are coming out there, and they're all being developed by research organizations, universities, and companies. And I think hobbyists need to jump in there and start playing.
Yeah, yeah. I'm looking forward to making a soft robot in the next few weeks. Gonna learn mold making. Woot woot. So cool. All right. Thank you so much, Andrew. And where can we find out more about this robot?
I will. It's coming up in I think the next published issue, which is May. I forget. Wow. I'll comment when you post this on YouTube. I'll put a comment.
Awesome. All right. Thank you so much for joining in and showing the robot.
Thanks.
And yeah, hopefully the robot hand will just remain there on the table and not try to crawl away from the robot. Okay. All right. So hey everyone who joined in while Andrew was showing his robot. Thanks for joining in. Next up, we are going to go to the Oregon State Robot Lab, I guess. I'm so curious to know more about this.
Yeah. Well, thank you. Can you guys hear me okay?
Yes, we can hear you. What is your name so that we can refer to you by
my name is Christian. The robot's name is Atreus. Atreus managed to lure me in here today. Let me stop the screen share for a second so you can actually see me talking to you. 1 second. Cancel. There you go. So yeah, so I'm one of the researchers at the Oregon State Dynamic Robotics Laboratory, and one of the things we're building is a robot called Atreus, and it is a bipedal robot that's designed to walk in a very dynamic fashion. Maybe I'll put the screen share back up so you can see the robot here. I have the robot in the room with me right now. They're just hammering away next to it, so it might be a little too loud to be next to it, but I can show you things on the robot. But as you can see, hopefully in the video, this is it's a little biped, but it's a bipedal robot. But one thing you might notice is very different than other bipedal robots you might have seen, is that it has very tiny legs, so you can't rely on the polygon of support from your feet in order to stay stable and upright. And that means we have to, in order to stand around, we have to be what we call dynamically stable, and you have to kind of just keep stepping and moving around at all times. So another thing you can kind of see, you might see those kind of trapezoidal black plates on the front of each of the legs there. Those are leaf springs. They are made of fiberglass, and the idea is that they are actually acting as the robot's suspension. And every time the leg hits the ground, the springs absorb the energy of the impact and just kind of spring it right back into the gate, which allows us to be a lot more efficient in how we walk. One of the primary motivating factors with this robot is that legged robots are really cool right now, but right now they're pretty inefficient. I'm assuming everyone's heard of Asimo. The robot Asimo. It's a really great machine. But one thing that's kind of that's not advertised is that the amount of energy it takes Asimo to walk, if you compare it to the amount of energy it takes a human to walk, it's about 16 times as much. And that's enough to have about an hour of battery life when you're doing a demonstration like that, which is really cool. But if we're going to make robots a little bit more practical and getting around in human environments or going into disaster zones, we want them to be able to last a little longer. So that's one of the motivating factors of Atreus. So one thing we're gearing up right now to do is to take Atreus to the DARPA Robotics Challenge. Now, can I just get a show of hands of who's heard of the DARPA Robotics Challenge here? Okay. Oh, a lot of you guys. Cool, cool. Nice. Yeah, it's so we won't be competing in the challenge. We're actually we're invited as a demonstration of, I guess, next generation technologies, quote unquote. I'm doing air quotes. You can't see it. And basically, there's supposed to be a much more efficient legged robot than what they're doing at the challenge, just as a demonstration. And what they're going to do is they're going to set us up and hopefully do a show in front of the audience. So we got about 94 days until that. So you might find us. So you can go check us out on Twitter. We've been posting a video every weekday of our progress of doing things with the robot, and going to the challenge. It's at Atreus Robot. I'll put it in the chat right here so people can see it. Yeah, there you go. So that's what we're up to. So, but I'm happy to answer more. That was a bit of a general overview of the robot, but I'm happy to answer questions about it.
Wow. Well, first of all, thank you for coming on to the robot party. That is just amazing. I don't think we've ever had a robot of this caliber on the robot party yet. Though, like, some of Adam's robots are pretty crazy, too. So, wow, so many questions. How many people are working on this robot?
Very good question. I mean, I'd say when we were building it about a year or so ago, and during the building process, it was probably about 10 undergraduate students, about 5 graduate students, and a postdoc. We were all working on it, and we actually built not one, we built 3 of these things. We were contracted by DARPA to build 3 of them. There's one at University of Michigan, where a guy named Dr. Jesse Grizzle, who's an excellent controls theorist, he's got one of these, and Carnegie Mellon has one too. So that's about the number of people. I'd say at our peak we had about 20 people working on it. Now it's scaled down a lot to just people doing controls and maintenance. So I'd say it's closer to 6 or 7.
Is it electric or pneumatic?
Good question.
When the springs fail, do they fail quickly or do they just tear slowly?
We haven't had the springs fail. In fact, one thing I guess it's getting quieting down over there, but I can give you a close-up. Number one, they're electric. Everything on here is electric. It's all going to be battery powered on board. Right now, you can see in that video there's a cable that's running to our off-board batteries, which are right now four car batteries, giving us 48 volts. But we do have the slots in there to put in some lipos on board. Number two, those springs are the last thing to fail for the most part on that robot. Right in those kind of orange-colored knees, we had to, of course, make the robot orange because that's Oregon State colors. There are little acrylic safety pins in there. And if you watch some of our videos, you'll see the legs suddenly break off for almost no reason. That's the safety pins failing. So that way those fail and not the springs.
Wow, what a great idea.
Just to be totally facetious, is it orange and black or is it blue and gold?
I only heard about that yesterday when I was going on Twitter. I was like, what is this dress everyone keeps talking about? It was very it's trippy. So yeah.
So how is the robot controlled? Is it running the robot operating system?
We used to run on a robot operating system, but now we're running it off MATLAB because a lot of our collaborators were doing a lot of their work with MATLAB, and we found that their simulator is a lot more accurate than the simulators you're getting with robot operating systems. So we're running off of that now. Not to keep plugging the videos we put up, but we do have a couple videos showing kind of our simulators in MATLAB alongside the robot. So that's what we're running right now. On the machine.
The simulators you guys using, is that Gazebo or?
I'm sorry, I can get further away from the hammering. I'm sorry, I can't hear you. Again. Sorry, could you repeat that?
The simulators you guys are using, what is that? Is that Gazebo or, you know?
Oh, the simulator is actually it's used in mechanics in MATLAB. It's
org-based or?
What's that?
Is it Ogre-based or org-based? What's the engine behind it?
Oh, the engine behind it? I mean, it's MATLAB's own software. I mean, in terms of they'll formulate the equations of motion and just integrate them with their own integrators. So it's not using Gazebo, it's not using Bullet, it's not using those sorts of things. It's
okay, so is it 3D or is it just giving you like data?
It's doing it in 3D, if that was the question.
Okay.
Yeah, so like what it'll do is you'll take in sim mechanics you'll take a body. It'll say, okay, here's my body, and it'll maybe like a bowling ball, and it'll just give it a mass, and you have to define all the ways that it can contact things, and then it'll kind of figure out the equations of motion, and then just integrate them themselves. It's a different.
Is there a physics engine also based in there as well? So if you do like different types of terrain or? Oh
yeah, we can do different kinds of terrain. There's, again, apologies, but there's a video that you can find on our YouTube channel that shows the robot when it was on its kind of this robot kind of falling off a little mini cliff, and then trying to recover. So
what
yeah,
degrees of freedom are there in those limbs that you have? What's the articulation?
What's that?
What's the degrees of freedom you have in the legs?
Oh, great. There are only 6 motors on this robot. There's 2 in each leg in what we call the sagittal plane, so that's like front to back. And there are 2 motors that are controlling its hip adduction, which is like the angle of the leg, and 1 for each leg. So you can kind of see in that video, there's like a little gray thing jutting out the top that's kind of pushing back and forth. That's like a half pulley that's being pushed around by the last 2 motors I was talking about. So because there's only 6 motors and a lot more degrees of freedom to the robot's heavily underactuated, which makes a lot more difficult.
Almost like a Delta robot, basically.
Like a Delta robot?
Right. The way that the articulation is.
Yeah.
What's the payload capacity? Do you know?
The payload capacity, that we haven't checked. Thursday's video showed taking 1 leg and trying to get 50 pounds or something, and the knee kind of blew up. So I posted a video of that. But it's more a demonstration of, can we walk around with so few motors and with a lot less energy. So, but I think one thing we might try is loading it up a bit and see how it sags. That might be fun.
Awesome.
How much does it weigh?
About 120 pounds.
I would love to see a video of you guys catching it when you turn the power off.
Oh boy. You can see there is a video of the safety rope catching when the robot powers when the robot shuts down or when it's an emergency stop. One video I guess we'll have coming up, I guess in the next week or so, is we took the robot and we threw a bunch of dodgeballs at it just to see how it would respond. And the last dodgeball, I guess, spoilers here, it hit the emergency stop button and the robot went boom and hit the catch rope. So
I got one last question.
Yeah.
What kind of processor are you using, and is it Linux based, or what are you guys running?
The control computer on board, I believe, is a Linux-based one now. I don't know because we just switched it out and our electronics guys had it. But the computer that's on board is very much just like a PC you can just buy online, which is I think it's running Linux. All the microcontrollers on board, we actually have we do have a Google code page with all that microcontroller code describing, and also describes how these boards are designed. We call them medulla boards, kind of roughly analogous to how I guess the brain operates. I didn't design them though, but basically for every motor on this robot, there's a different board and we custom designed this set of boards so they can all communicate with each other over the EtherCAT protocol, which gives us a kilohertz control rate, which is pretty good. We feel like we need a really good control rate to make sure that this robot is keep moving. So, but all that information is fully online in lots of glorious detail.
I guess it's all done on board processing. Do you have another computer that's also calculating?
It's all on board processing. The only caveat is that the computer is technically that's going to be shoved into the robot is technically off the robot right now. The guys are hammering away on the robot as we speak, trying to make some space for the computer on board. But all the computation will be done on board, only with some kind of basic commands coming from a user, which right now we're controlling with a PS3 controller.
Cool.
How small could you make this robot?
Ooh, good question. People have made similar versions of a robot like this with the spring legs that have been tiny, like the size of your hand. But they were designed mostly just as kind of they're kind of designed as sort of test bed platforms for certain scientific studies. I'd be curious if someone can do that, take a similar idea of putting springs in your legs and be able to have it walk around in 3D, kind of like we're trying to do here. That I haven't seen yet. But I imagine you can make it pretty small. You probably can make it about the size of your hand. And because it's so tiny, I'm assuming its strength-to-weight ratio might be really cool. And they might be able to do all kinds of crazy maneuvers. Like when I think of things like that, I think of the sand flea robot. Do people know the sand flea robot? Show of hands. Yes. So if people haven't seen that one, it's Boston Dynamics. It's a little tiny robot that jumps on top of buildings and things like that. Yeah, and I see a comment about similar robots in Japan. I'm thinking of in terms of spring-legged robots or in terms of bipedal robots. Spring robots. I'm thinking of who that might be. But yeah, I'd be interested to hear if anyone's seen other similar robots to this. That's really cool. Awesome.
Still sounds like you're in space, Michael. Sorry.
Could anyone hear what he's saying? I'm sorry, I'm trying to hear.
We're getting like 1/8 of what
Yeah,
he's
his microphone is really
saying.
low. Can you hear me now?
Oh yes, we can. Yes, thank you.
There's a couple of people I know in Japan that have legs similar to that, there's also a very fast robot that has spring legs that competes at Robo 1. I'll post a link to the videos of the really fast robot.
Yeah,
But
I know there's one in. I think it was one in Korea. I thought it was like that was the really fast robot in 2D, and they basically had a little tail on it, quote unquote, which spun around and kept it stable. It was very cool.
Right. Yeah, I'll post links to it. I've seen those. I think they started bringing. They call them parallel legs, where they have linkages and springs that amplify the movements of the servos. I think I saw them in 2010 and 2011 and 2013 at Robo Games.
Cool. Are they smaller robots? Like, what's the size of these robots? So I get a sense.
They're human robots. Some of them are less than 2 kilograms, and others are over 2 kilograms.
Oh, I see. So okay, now I'm getting a sense of scale. I see.
Yeah, I think the ones he's referring to, there's actually the robot I think he's referring to is called Frosty.
Right, Frosty. That's it.
Designer. It's really small. It doesn't have spring legs, but it used the parallel leg design. So it's just a power to weight ratio basically. But it looks very similar to this in the way that it's designed.
Cool. Yeah, I mean the parallel legs have a number of advantages we've found. It's one, they're really light, especially those are carbon fiber tubes that we have for legs. So that way, when the robot smacks the ground every time with each step, it doesn't lose a lot of energy, it doesn't create a big impulse that we have to damp away, and that's really handy. It also means because the leg's relatively light, we can kind of put it where we want to pretty quickly, which is nice.
Are there any environments where this robot would not be good in?
Underwater, for one. That's my first answer. In terms of legged robots in general, would not be what you'd want to drive down the street in, obviously. But this particular robot can handle rough terrain pretty well. At least in the simulators and in our 2D experiment. I would say this particular robot can't tightly maneuver. There's no like it can't turn like on a dime. In fact, we don't have a lot of controllability over how the robot turns from left to right. So if you were trying to like step around in like a really tight office corridor, it would not be very good. And we didn't really design the robot to do that, so it wouldn't be good there. But the robot is designed to go in rough terrain.
Yeah. Wow. Cool.
Is there any plans to make it maybe a quadruped, or are you just thinking just bipedal at this point?
Well, this project finishes up at the end of the demo, and I think that this is the last robot you're going to give this particular kind. But the next robot I think will again be a biped, particularly one that is better, one that can hopefully take a fall better than this one can. We're a little afraid to take it off its safety harness.
Do you think a robot with this type of schematics will be able to get up on its own?
With this kind of configuration?
Right.
It would probably need arms. Like if it fell on its side, it would need arms. Or fell at all, it would need arms to get back up. So the automatic getting back up policy will be us humans running around and trying to pick it back up again. Yeah. So
how did you get started building robots leading up to one that's as huge as that?
Well, I'm more of a theoretician kind of guy, so I kind of started back in Bucknell University on the East Coast, and I did some simulation work on legged robots, and I met Dr. Hurst, who is the PI here at this lab, at a conference, and decided that I would do work with him for my next thing. So I just kind of got into it by talking to people at a conference, and now I'm here. So, but of course, if you want to see all the people who are involved in getting this robot going, of which there are many, and they spend a lot of time, you can go to our website, which is linked through our Twitter feed at Atreus Robot. So yeah, but it was a good. I was in FIRST Robotics as in high school. I guess that's probably what really got me started with robots.
Oh, nice. Very cool.
What's the total cost of this project? Like, what are we looking at as far as funding?
If you want to know the total cost of the project from the start, where we had to design and build the 3 robots and design it from scratch, I would say it was about $3 million.
Whoa.
The robots themselves.
All funded through DARPA, I assume, or?
Yes, it was a DARPA grant. It was the DARPA M3 program, which stands for Maximum Mobility and Manipulation. There were a couple of granted proposals on this track, which was basically making the next generation machines more agile and more maneuverable. So we got a grant to build these 3 robots. There was a grant for the Fast Runner project, which was through IHMC. That became the Outrunner. I think the ultimate product of that was the Outrunner robot. I'm not sure if people have seen that Kickstarter, the Outrunner robot. I'll post a link to it in the comments after I guess I'm done. That was cool, and also they funded Boston Dynamics. I think they funded the Atlas project. Yeah, the robot does need to go to the restroom. I think I actually joked about that on the Twitter feed. So Boston Dynamics got a grant, and Songbei Kim, the guy who does the electric robot sheet at MIT, he got a grant. So those are the people who are kind of doing this style of robotics.
Wow. Well, thank you so much for taking the time to join in and show it or explain it to us and show this video and everything.
No, thank you very much for the invite. It's really cool to see what all you guys are up to, and also, I guess one thing I should put out there is we're still figuring out exactly what we want the robot to do for this show. So if you think of fun things that maybe a robot that looks like it has to pee at the bathroom to do for a big show, we're open to them. And you can check us out on our Twitter feed at HVSRobot. We're posting videos all the time.
It sounds like a job for robot cockroaches.
Cool. All right. Well, thanks guys for listening. I appreciate it.
Cool. Thank you. That was awesome. Wow. All right. So next up, we'll go to Atom. Yeah, you always have cool robots too. What have you been working on lately?
Actually, I didn't decide to do anything like super advanced. What I did was because I know a lot of people on here, they're trying to build robots very cheaply. So what I did was I got this Meep robot. It's by Wowie. So what's cool about it is actually on the back side, if you open it up, it's got already a serial port dedicated so that you could hack it. So
Nice.
what I did was I kind of hacked it. I took the head off and I took because it has like sonar sensors here. I moved them because what I did was I put a model, the A+ Raspberry Pi on the back of it, and I've loaded OpenCV so that I could use the Raspicam to do object detection and just maybe even line detection. So you could do like a line follower. And right now it's just all made out of cardboard because it's just kind of like a test bed. Eventually I'll put a servo on this so that it could look down and then it could track balls or track lines. But basically that's about what it is. It's just so I do all the processing on the Raspberry Pi, and then it sends the commands through the serial port to the robot. So it's just basic commands because they have API level functionality within the serial port. So you can just send your basic commands to it that it expects over Bluetooth to control it. So like left, right, the speed of the motors, and also you can get data back from the robot as well. It's got limited sensors, just like I said, like this sonar sensor over here. I'm not sure. I don't think it has encoders on the wheels. It may. I haven't looked that far into it. And also I put MGPG server, just like the port forwarding video, so that I could actually drive the robot around like through a telepresence page, like some of my other robots. So there's more than one, I guess, way that you can utilize the robot. So basically, it streams, the web video, and then I made like a little Android app so that I could control the Bluetooth robot and see the image as well. So that's basically what I've got. I can probably start him, but I'd have to SSH into the kernel in order to get him to run. And what I did too was, because I wanted to power the Pi, I wasn't able to power it with just the battery pack that was on the robot, which you can actually tap into it, but the Pi actually takes too much voltage in order to power it. So what I did was I got one of these little, I don't know if you can see it, it's a really small, like the size of like a 50-cent piece, maybe a $1 piece. It's a USB phone charger type thing, like an emergency power. So So I completely tore it apart, and then I pinned it out so that on the USB, if you can see it, I kind of opened it up and just put pins there so that I could put in these other pins into it. So just, grabbing power from it instead of having a USB cable that's kind of big and bulky and then plugging it into the Pi. And the same thing on the Pi, I've actually gone in the back and then gone where it has the resistor. So instead of powering it, by the USB port, I've actually come back and gone behind the board and grabbed power directly where it would be located on the PCB. So.
Wow, what a hack.
It's kind of all over the place. So right now, it's actually, let's see if I can, what's cool about this robot is it'll already stand up, right? Because it's already got, gyro sensors on it. Let me see if I can, I have to take it. So I don't really have to program him right to stand up. It's already got that on his own processor. So I'm just calling, go forward, go left. And I'll see if I can pull up his video image because I think he's logged into my network. Maybe I can share it. And then I'll drive him around possibly. Let's see if that's even possible.
And the sounds, are they automatically triggered, or?
I think he's mad because I haven't put him down. He kind of makes noise when he's not standing up. Let's see. And I was actually gonna take out the audio on it and then put like a speaker, but there's not much. There's not a lot of a lot of room to put extra stuff on it. Let's see if it's ported to my. Looks like yeah, I don't know if I can grab it. I'll try to grab the video that's actually being ported onto my network. So I have to check his IP. So I'm not the SSH on. So that's all I've got for today.
That seems quite involved for just a little quick hack.
Yeah, it's like like I said, the majority of it is really in the code through OpenCV to track like balls and things and stuff like that. That's really where primarily what I wanted to do is just try to take a simple robot like this and have it track balls like my other humanoid robots. But this like I said, I bought this really cheaply. It was under $100. You can find it probably used for even cheaper than that. And then the Raspberry Pi is, it's an A model, so it's like $20. So all in all, maybe for under $200, you can have a robot, that you can do ball tracking, line following, and then kind of understand some things like Python, C++, vision processing with OpenCV, things like that. So it's kind of mostly like a tool to help people, learn how to do some of this stuff in robotics. And I guess in the future, here at the Science Center in St. Louis, we're going to start doing just kind of like demonstrations and maybe some informal talks and try to teach people on how to do some of these things.
Wow, that sounds great. It's really cool, the idea of taking like robots that are like existing as like toys or entertainment and then hacking them to make them even more intelligent.
Right. I mean, it's like I said, some of the robots that I have are so expensive. There's no way people can really start to play with them without spending, $5,000, $6,000, $10,000, and just not feasible for the average person. So that's all I got today.
That's a really cool project. I actually have one of those guys. Now I totally want to hack it.
Yeah, the SparkFun actually has a board that you can put on the back of it. But because I wanted to try to make my own version, and they use a BeagleBone Black, I think, to incorporate. But I wanted to use the Raspberry Pi because it's kind of a smaller board. Mm-hmm. And eventually, I was gonna 3D print this and then put a new, make it custom, make it look cool. But it's still obviously in dev.
Are you? Have you published what you've done anywhere, or is it?
Unfortunately, I've been so busy. I hate to admit it, but yeah, I'm really bad at documenting. I used to try to do stuff on Google+, but I have so many robot projects and so much going on. It's just really hard. But that's why I'm with the St. Louis Science Center. We're trying to be more open. So I'm actually one of the founding members of the robotics group here, which is robomo.com, and we try to influence other people into computer science and robotics, and we meet at the Science Center once a month. So hopefully will happen more frequently, and then we can actually sit down and have tutorials and maybe even some small classes set up just to get people involved in some of these things with code and robots and stuff.
Cool.
That's fantastic.
One last thing, I wanted to say that whenever I did it with Raspberry Pi, instead of using like the USB serial port, I just went to the standard port that's on the Raspberry Pi to send these messages. So I was trying to do things kind of as clean as possible without a bunch of wires hanging everywhere. But yeah, you definitely have room to do more with something like this.
It's going to be great that you're going to do some of the help introduce people to robots sort of outreach stuff.
Yeah, I'm hoping.
I always find it strange how it's so easy to learn how to draw because having a piece of pencil or a piece of paper and a pencil is so accessible, but then it's not as easy for robots because it's not as accessible. So by having more of that, maybe more people will realize how cool it is to work with robots.
I think what it is too is in robotics, it's a very high learning curve. So a lot of these things people aren't familiar with, and just programming in general is hard to tackle just when you're not familiar with it. Just understanding how things work, it's really hard to grasp it without somebody really over your shoulder explaining things. But I think as software gets higher and higher level, you're going to have things like APIs where you're not doing a lot of specific code. It's just like you're calling certain functions within these small programs, and then it does something that you want. I think that's probably the best situation, is make the code small and reasonable, kind of like how Python is. It's understandable so that average people can kind of grasp it, and then it might push them further to develop a further understanding of things.
Great. Well, thank you again for showing your robot at the robot party. This is great.
Thanks. I'll try to. I have a GitHub too, and I'll do my best to do some documentation on it. So you guys, if anyone's interested, I'll put my code and stuff on there. Most of the code is already open source already, so I just kind of put stuff together. There's a small programming C++ program that I built for ball tracking specifically, but the majority is.
Great. All right. So that is pretty cool. Thank you again. And next up, we're going to go to Robert, Robot Goldfish.
Yeah, I was feeling bad because I didn't have anything to really accomplish, and now I really feel bad. I did find.
Don't feel bad.
I did find the battery connector I was looking for.
Oh, great.
It's a Molex connector. I got a message from one of the viewers, John, who also, I had found it already, but he had sent me the thing, the link to it also. I've been building this is a AT-Tiny 85 surface mount, which is going to be my next set of brains that I'm going to be playing with. These are neat. This is a little clip that clips onto the surface mount chip, and it has contacts in it so that I'll be able to program the chips when they're in circuit. There was some talk about casting early on, and first of all, Smooth On has some great stuff, but there's a book I found years ago. It's called The Prop Maker's Guide to Molding and Casting by Thurston James. It is an absolutely fantastic book on making molds and casting.
Oh, nice.
And This is my robot that's going to be a toy conversion when I get around to it.
Oh boy, a big brother to the meat robot.
Yeah. Yeah, he's from the 70s, but man, there is a lot of space in him. I can, I can do a whole bunch of stuff there. But no, that's about it. I don't really have anything to share. And nice to see you back, Andrew. I judge from the box of foam you're still working on the house. So hang in there. But that's about all I got. So.
Can you tell us just a bit about the circuit board that you made? How did you create it?
Well, okay. It's a. I think it might even be a surfboard, but it's a surface mount breakout board that you can see in some surplus outlets. You can also get them from DigiKey. And it's just the surface mount version of the AT-Tiny 85. And all I put on it is a resistor between reset and the, I believe that's the high rail. So I can ground out the reset pin. This one has a header for the reset. And that's about it. I mean, the one thing I really love about that chip is it's an internal clock. So you just hook up voltage to it and tie the reset high, and the rest of the pins are to play with. So it might only have 5 pins, but you get creative and you can have fun with it. Like this is a AT-Tiny 85 circuit. This is the
oh wow, okay.
Maker Faire hat, and
Oh, wow.
I'm using the 5 output pins to control 6 LEDs.
Neat.
But yeah, no, that's an attention grabber. It's still the same batteries from Maker Faire, and it is blinding. But no, that's about it. I'm afraid I don't have a whole lot to talk about this week.
Well, thanks for showing your robots anyway. It's always neat to see the projects in progress.
Oh, it's my pleasure, and I'm always up for a robot party.
Okay.
Talk to you next time.
Thanks. So next up is Michael. Oh wow, look, it's a little robot bird. That's pretty cool. Okay.
Yeah, hopefully you can hear me now, but yeah.
Yeah, we can hear you now.
I put this one together. This is the penguin from the Robotics Pets kit. I did it for the makeout because I know how you like birds. It's the penguin. He doesn't do a lot. He just spins around. It's a kid for 6 years and older. But I'm just thinking now to see what everybody else is doing. I would mention Robo Games. I think there's like 14 days more to register for Robo Games, and it's the first week of April. I don't know if everybody's heard, but Grant, formerly a Mythbuster, is going to be there, and my friends from Japan, Shibata and Omada, have just signed up to come to Robo Games.
Awesome.
So, yeah. So.
Are they going to be bringing any new robots, like any new humanoids?
Shibata is working on a robot. I don't know if it's going to be done, but he will be bringing Thunderbolts. And then Omada has the robot with the wrestling mask on and everything, and he's really popular. Robo One, he'll be there too. So it's going to be really cool.
Are they still going to have the combat robots with the arena?
Yes, if you like BattleBots, Combots, yes. I think almost all the weight classes are filled up now on that. There's going to be nonstop action in the arena from Friday to Sunday night. So yeah, it's going to be super cool. And I did get a Raspberry Pi 2 in the mail today. I'm just curious about what everybody else thinks because I really like the Raspberry Pi, and the 2 makes it even cooler because of speed and the memory capabilities. I'm liking the Pi better than like the Edison and the BeagleBone. So I just got that when
I use the Pi 2 myself because I wanted to test it against like the Odroid. Because I use the Odroid a lot for OpenCV. Didn't notice that Pi 2 is a little bit slower, but obviously it's more accessible and you've got more users using the Pi, so you're going to have more libraries built for it, and also you've got things like shields and stuff for it, which is pretty cool. So I mean I use it. It's pretty nice. I tested OpenCV on it. It works well.
Yeah, with the Pi 2 and this faster memory and faster speed processor and more memory, it's going to make it even better.
The only thing I was discouraged about it was that it wasn't using flash memory for the OS. But other than that, I mean, it's fine. I guess they're trying to keep the cost down, just using SD cards for it.
Right. I think and you'll be able to get a free version of Windows 10 with it now too, if you want to use Windows 10. So. Cool.
All right. Well, thanks for that update, and yeah, good info and everything. Thanks for dropping by, Michael.
Yeah, no problem.
Next up is John. John, can you show us your robots?
Yes, I have developed competition for the Oregon State bipedal robot, and mine did not cost $3 million. The chassis for this robot cost $3.
That's pretty good. That's pretty good. Pretty good.
So,
I want to know your secret.
right here, and is my robot. This is a gyro-stabilized bipedal robot. I'm going to pull my camera down here, so I hope I don't make anybody sick.
Oh,
See if I can.
$3.
I'm glad that somebody enjoys that. Okay. So there it is. And I'll plug it in and turn on the my camera is wigging out. My camera is I did something to it to use it on a robot, and it's never been the same since.
Oh my gosh.
Okay, so there's the robot and how it acts without the gyroscope running. It doesn't do very much. It's kind of clumsy, and it very occasionally falls over. Now I'll start the gyroscope up. And now it walks really quite reliably.
Wow, that's awesome. Is there any way to control the locomotion?
Yeah, you mean
Like the direction or? Yeah.
Yeah, how it works. Let me shut the gyroscope off.
I guess you could add some weights on the side of it to pitch it left to right.
Well, how it works is when the gyroscope is running and the servo pushes this foot down, the gyroscope tries to lean this way, but because of gyroscopic, you guys can't see that, because of gyroscopic precession, instead of falling sideways, it rotates. And then when the servo puts the other foot down, it tries to fall the other direction, but again, because of precession, it rotates around the other foot instead.
So I guess the faster you run the gyro, the more the tighter the steps or the longer the steps would be. So you could actually do that.
Yeah, you can control the direction by keeping one foot down longer than the other.
Mhm.
Yeah, it's interesting because I like that. So I'm guessing if you were to slow down the video, you would see the the foot the planted foot slip a little bit more or less depending upon how much you want to turn it. That's cool. I like that.
So
That's awesome design.
and it is, most of the robots I build are very cheap and very small, and hence very safe to be around. This is the only robot I have ever built that has drawn blood.
Oh boy, what?
This this flywheel here is a flywheel that I scavenged out of an old VCR, I think, and it has got gear teeth around that, and it is spinning probably 6,000 RPM when it's up at full speed, and you just brush up against that the lightest bit and it will take your skin off just that quick. And the first couple minutes I had this thing running the first time, I drew blood 3 times, I think. So
You have to print out the little cage for it, then I guess.
yeah, I do. I need to build a little like body for it or something. Yeah.
Is there a featherweight division for BattleBots?
Here we go.
Yes, I believe there is.
So I was about to ask how fast that was spinning. Do you have any sense of how much inertia is being what I guess the equivalent of that angular momentum is required for to keep that thing stable? Because that's really cool. I'm wondering how big that would have to be on the scale of something, say human-sized, just to pick a random example.
Yeah. I could probably look through some old textbooks and find the equations to calculate that. I have not made the attempt to do so yet.
That's fine.
This
weight of the robot, I would assume. Is that about accurate?
Yeah.
About 3 times the weight of the robot?
Well, how heavy is the wheel, I guess, is a better question.
How heavy is the wheel? Well, the wheel is, well, it is the heaviest part, the heaviest component in the robot, but it's not extremely heavy. And when I first, it's being powered by a little Mabuchi hobby motor that's probably only supposed to be run like 3 to 6 volts, and I'm running it at 12 volts to get enough inertia with it. So if the robot walks around for a few minutes, you begin to smell ozone.
Oh boy, okay.
I guess if you wanted to get something more complicated, you could have to actually put encoders on there so you know how fast it's spinning. Instead, otherwise, you estimate it based on how much power you're feeding it. If you want to be able to truly control the locomotion.
Yeah, and I'd need to refine the gear train too, because right now it's, the motor is way over here on the side, and it makes the center of gravity of the robot over on this side of the robot. And with a better gear train, I could get the motor more in the center, and it would walk better that way too.
What did you use to create the pieces of the robot?
It's 1/8" MDF hardboard, and I cut them on my Shapeoko.
Cool.
And it's mostly bolted together with 440 hardware, but there are pieces that are glued with super glue.
How much do you have to play around with that stepping frequency to get it to go well? Is there a good range, or is it super easy to find that kind of stepping frequency that you have?
It didn't take me very long to get it to work right.
Cool.
I don't know, half an hour of playing around with it.
that just shows how generally stable it is. It's pretty cool.
Yeah, I think so.
All right. Well, thank you so much for showing this robot the $3 competition to a $3 million robot. That's kind of funny.
I should be fair. It's the robot itself is a lot less expensive. I think the students, yeah, we're pricey.
Oh, okay.
You know, if I were if I were going to pay for my time that I put into building it, it would cost a lot more than $3.
Yeah. Very cool. Very cool.
Thank you.
Great. Okay, so we're running a bit over time by 5 minutes now, but we still have some people left. So, Chris, do you have a robot to show?
Yeah, but if we're running out of time, it's not finished yet, so.
Can you just show it to us? Like, just show us what it is, and then say what it's supposed to do.
Okay.
This is the robot party, after all. Oh boy, it's a giant robot.
Yeah. So I made this. This is about my 4th iteration of it, and what it's eventually going to be is my golf cart caddy. It's going to carry my golf clubs, and it follows me around. I have some videos that I made, but I had to change the wheels out. I started out with some 10-inch wheels that go on a cart, like a wheel truck, like the Pepsi guy moves around, but they spun out on the grass, and I couldn't get any traction. And then the wheels were just a little too slow. One of the problems I had when I had it out this last weekend testing it was it was too sloppy and it had a solid axle, so I had a threaded rod used there for the axle. One of the nuts come loose and it started threading down the rod, and it pushed the motors and all the gearing into the frame and broke it all up, and I had to pack at home 2 blocks. And so I switched to bicycle tires now if there's a problem, because they're freewheeling, and if I have to, I can drag it home.
All right. Well, I think we're all going to look forward to seeing this in action, and maybe in the next robot party.
Yeah, I've got some videos of the old one, but I didn't get this one done in time to make any videos or anything. See it going. Quite frankly, I got a code snafu. I was kind of hoping maybe after the party I could find somebody that knew and could help me a little bit.
What are you using for following a person? Are you using just discrete sensors, or are you using like Kinect, or what were you thinking about?
What I've got is I've got it run 2 different ways. I've got a USB camera on it, and I was using OpenCV and putting my face in. I put a real wide rectangular, and it looks for my face, and if my face is over here, it turns and always tries to keep me separate, and so it stays ahead of me. Or I've got sharp infrared sensors on all the corners and in the centers with a different algorithm that makes it follow me by the infrared sensor.
Awesome. Is that, you write it in Python, or I'm just curious. Is it C++? Like, what type of code? I mean, I'm really interested in helping you. Maybe try to. It seems like an interesting project.
Cool. Well, I appreciate that. I originally started with on a BeagleBone because the Raspberry Pi doesn't have analog. So I bought a BeagleBone, but I'm having such a hard time getting through those device tree overlays that I just went back to an Arduino. So
I think if you were going to use like a BeagleBone to do like facial tracking, you might have issues because it's not going to run at a fast enough rate in order to keep up with your face moving around. And also you have issues with like the resolution. I mean, you run at a higher resolution, it's got to calculate more pixels. That might cause an issue. But I mean, like I said, I use the Odroid, and it's almost about the same as like a Raspberry Pi or BeagleBone, and it does OpenCV fairly well at a high frame rate. I would say like around 15 to 20 frames per second, which is adequate to track faces as long as you're not running from
yeah, I haven't in some tests I haven't had that big of a problem because I'm out in the wide open and it's pretty easy to find a face and and track it and stuff where everything's just all green behind me, and so the frame rate doesn't have to be that bad. But I think these sensors, the IR sensors, are really working out the best for me and are pretty stable. I've had to put them into an array and average out the readings because I get some outliers once in a while, and that gives me some problems. So I think the Arduino is going to be the best, but I've got a Bluetooth on it so I can control it with my phone, but I can't. But I just started. I'm an old guy, and my kids are all grown, and so I just started doing this about a year ago. But what I'd like to do is I can either control it through Bluetooth with my phone, or I can control it, let it run autonomously with those infrared. And the problem that I'm having is writing in Arduino code how to switch between the two.
Switch states between programs?
Yeah, just so that I could either run it with my phone, and direct it remotely, or have it autonomously.
That's not an issue. I mean, like I said, it just depends on what you're using. If it's just Arduino based, that's not too bad. But if you're running like Python script on a BeagleBone, you probably have another Python script to run like OpenCV later, or communicate with your Arduino. And then you can always set up variables to determine what's happening. If it's getting information from OpenCV, is it getting information from you, and which one's more equipped to deal with it. So if you want to override OpenCV, you could do that. So yeah, I could try to help you with that. Sounds interesting.
Okay. That's awesome. I'll put my address on the chat if you want to, and then maybe we could talk. Because otherwise, then that'd about get me done.
Yeah, I'll put my email up on there as well, so everyone else is like maybe interested in stuff. I'm always looking to collaborate. It's always fun.
Terrific. That's awesome. I appreciate it. Thank you.
Nice. All right, collaboration. Woohoo! That's great. Okay. So yeah, thanks Chris for talking about your robot, and thanks Adam for helping out. That's pretty cool. All right, so I think we got everyone. David, do you have any robots or anything to share? It's okay if not. Nope. Okay, guess not. And Stephen, any robots to share? It's okay if not. Just didn't want to miss anyone before the closing of the robot party.
Oh. I don't know if you can hear me.
Yep, we can hear you.
I'm having kind of some problems here. Yeah, I don't have any updates with my project. Things have been kind of slow recently, but I'm just kind of working on. Like gate, walking gate code in simulation right now. So at some point in the future, I will have this coded up and then get it out onto the robot and hopefully have something to show in the future.
Cool.
It's still my existing project, part of which I showed last year. So it's all part of like a bigger project still.
Cool. Is this your own personal project, or part of a lab?
It's a personal project. It's like a tele-robotics project using a quadruped robot. So I've been kind of studying, like most everything that I do myself. So the robot build that I have is part of a robotics kit. So I'm using like AX12 servos with 4 degrees of freedom per leg, and I basically have been off studying like walking gaits recently, trying to kind of brush up on walking gaits, and I'm coding up my own walking gaits basically because I want to like fully understand how gaits work and how to apply those, just so that I have more control over what I can code up and what sort of algorithms I can write up myself, rather than relying on any stock like code that's out there.
All right. Well, good luck with continuing on your project, and I hope to see that robot in action next time.
Yeah, you know, if I don't have like the robot itself going next time, hopefully I'll have at least something in simulation that I can show. Because it looks like I could like screen share and stuff in here now, so maybe I can do that too.
Okay, cool. All right, and David mentioned that next time his daughter is excited to show off a little four-wheel drive thing we made together. So great, okay, that will be really cool too. Okay, so sorry everyone, we went 15 minutes over time. I hope that the robot apocalypse is not delayed because of us. Or whatever.
It wasn't delayed, we just didn't notice it started.
Right, okay. Thank you to everyone who has joined in to show off their robots today and offer help and everything. That's really great. And I'll post more info about the Robot Party Dance-a-thon, I guess, on Google+. So if you join into the Robot Party Rockstars group, then you'll see some of those posts there. And until next time, and thank you to the viewers for watching. And until next time, I hope everyone has a happy hacking with robots and making them all work and everything.
Thanks for having us.
Oh, cool. Yeah, no problem. Yeah, live long and prosper, everyone.
Thanks, Aaron. That was awesome.
Yeah,
Great.
thanks, Aaron.
All right, see everyone next time.
See you next time.
Bye.
Live long and prosper.